Hey guys, so hopefully you got the outline and have the foldable already cut and put in your notes. If not, then go ahead and pause this video and do that right now. That way you can go ahead and get started and be ready to go. Okay, so we're talking about exponent rules. Now, many of you have seen bits and pieces of exponent rules, and we're going to kind of go over all of them. I'm going to try and explain it as best I can, and hopefully you understand why the quote-unquote rules are what they are and how they work. So we start off with a radical expression. So a radical expression, it's just an expression that contains a radical symbol. The radical symbol is just that root symbol. So the crazy bar thing, that's the radical symbol. Now, we also have, so there's the first thing out of our toolbox. So we also have what we call an index. The index is what the actual root is. So like for this example, the cube root of 125, the 3 is our index. Okay? And then the radicand, well, that's what we're taking the root of. So the radicand is what is inside the radical sign. Radicand. So that's just some background info for you. Okay, so when you should already have your pieces cut out. So, whoa, why did all that move around? Don't know. So I'm just going to take some examples randomly and then kind of talk about them, and we'll put them in the correct places. Once we figure out how the numbers work, how the numerical examples work or algebraic, then we can put an actual rule to it and see if that helps. I know, my voice is still funky. It's okay. All right, so we'll start. I'll just grab this one, and I'm just going to pull it off to the side so that I have more room that I can work with. So it says x to the 4th to the 5th. I want you to see why the rules work. So it tells you if you've got a power to a power, we're going to multiply. Well, I want you to see why that works. Well, x to the 4th is how many x's? Well, 4 x's. So think about it. If we've got 5 groups of 4 x's, I'm not writing all that out because it would be crazy. How many x's would I have in here? 4, 4, 4, 4, 4, 5. That's where they're getting the x to the 20th. So why we come up with these rules? So that we don't have to write all of this stuff out a bunch of times, because, oh my goodness, could you imagine having to write out 20 x's? That's crazy. So if we have an exponent to an exponent, so a power to a power, we're going to multiply. And it's given a numerical example as well. So let's go ahead and find where, drag that where it goes. So power to a power. And now let's find which rule explains that. So we have the same base, we just keep the base and multiply the exponents. So something about keeping the base and multiplying the exponents. Here we go. Multiply the exponents, base stays the same. So go ahead and glue both those pieces into the appropriate spot. And again, if at any time I'm going too fast, feel free to slow this down, pause, whatever you got to do. Okay, I'm just going to grab another one. Ooh, I like this one. So I'm just bringing it over here so I have more room to work. So x to the 9th divided by x to the 4th. So again, this is telling us we subtract. Well, why do you think we subtract? Think about it. X to the 9th. How many x's is that? 9 x's. So if you ever forget the rules, you can always write them out longhand like this. Yes, I know it's a pain, but you're still going to get the right answer. And at the end of the day, usually that's what we want. All right, do I have 3, 6, 9? All right, so 9x's divided by 4x's. So if I go to simplify this, I can very easily, remember, anything divided by itself is 1, so I can very easily watch things cancel out. So how many x's are we left with? 5 x's. Bam, x to the 5th. So that's how that works. So we just showed it. We modeled why x to the 9th divided by x to the 4th is x to the 5th. Or if you want to make it easier on yourself, you can just remember the rules. When dividing, I subtract the exponents. All right, so let's go ahead and find our division rule and drag that over. There we go, dividing exponents with the same base. And then we need to say find the rule about keeping the base and just subtracting the exponents. Not that one. Here we go. Subtract the exponents, base stays the same. So we're going to go ahead and slide this up. And go ahead and glue those in. Again, feel free to pause this at any time while you're gluing stuff in. I just have to keep the video below 15 minutes or else it's not free anymore. All right, I'm going to find another one. Here we go. X to the 5th times x cubed. All right, so again, x to the 5th, how many x's? 5. So if I have 5 x's times another 3 x's, because remember, if you've got something to an exponent, that's multiplying. So x to the 5th is really just x times x times x times x, 5 times. So if I throw another 3 in there, how many are there? 8. So that's where they're getting this x to the 8th. Now, if you want to shorten that up so you have a quick rule, whenever we're multiplying and we have like bases, that's really key. The bases always have to be the same. See, even the numerical ones, the bases are the same. So we keep the base and we add the exponents. So this is our multiplication. So we're going to drag this on over. Multiplying with the same base. So that's going to go there, and now we need to find where it talks about multiplying. So we keep the base and add the exponents. Add the exponents, base stays the same. All right. All right, now this one we talked about on Tuesday when I was showing you guys when we go up like 5 to the 1st, 5 squared, 5 cubed, we're always multiplying by 5. So when we go backwards, we divide. So anything to that 0 power is going to be 1. And any number to the 0, any number except 0 raised to 0 is equal to 1. So here, since that's a long one, it has an extra example, even when we use it for variables. All right. Is this the last one already? Sweet. Negative exponents. So again, I showed you guys, and I'm going to demonstrate it again, why when we have negative exponents, we take the reciprocal. So let's say I've got the number 3. So I start off with 3. So 3 to the 1st is 3. 3 squared, 9. 3 cubed, 27. So our pattern, we're multiplying by 3. So if we work backwards, 3 to the 0, we divide by 3. 3 divided by 3 gives us 1, which we already talked about. Anything to the 0 is 1. Now, if we continue that pattern again, so if we divide by 3 again, if I do 3 to the negative 1, I'm not allowed to have negative exponents. I can't leave an answer written like that. It's a huge no-no. So I'm just going to divide by 3 and get 1/3. So once I take the reciprocal, my negative exponent becomes positive. So that's huge. Whenever you have a negative exponent, you're going to take the reciprocal and the exponent becomes positive. So we have one example where it's in the numerator and one example where it's in the denominator. As soon as you take the reciprocal, it becomes nice and positive for us. All right, so negative exponents, and take the reciprocal, keep the base, make the exponent positive. All right, so once you have everything glued in, that's awesome. I'm going to go ahead and do some examples with you. If you have time, keep going. If not, I'll catch up with you when I get back. Now, to remember these exponent rules, I've made up this mnemonic. Actually, I didn't. I take that back. An old student of mine and her mom, they came up with MadSim years ago, you know, like how we have PEMDAS and stuff like that to remember order of operations. So she came up with MadSim to help her remember the exponent rules. So it just stands for, get my colors right, whenever we are multiplying, we add the exponents. Whenever we are dividing, we subtract the exponents. And whenever we have an exponent raised to an exponent, we multiply the exponents. So you don't have to use this. Again, it's just a tool that I use to help me remember my exponent rules. So it's there if you want it, no pressure. So again, whenever we multiply, we add the exponents, dividing, we subtract. When we have an exponent raised to an exponent, we multiply. Now, let's go ahead and simplify some of these. So our first problem, okay, we have a nice multiplication problem. Negative, that was not pretty. Negative 4r to the fourth, s to the negative 1, times negative r to the negative 9, s to the negative 1. This is a lot of negatives to keep track of, so let's make sure we do this one thing at a time. All right, now first thing, think about what operation are we doing? Well, we're multiplying. So when we're multiplying, we add the exponents. So first I'm going to multiply my coefficients. So I have a negative 4 times, I'm going to go ahead and fill in a negative 1. So I've got 4. And then my r's, I've got r to the fourth times r to the negative 9th. So again, when multiplying, we add the exponents. So that gives me r to the 4 plus negative 9, negative 5. And then s's. So s to the negative 1 times s to the negative 1. So again, multiplying, so we add negative 1 plus negative 1, s to the negative 2. Now, do not leave your answer like this. Please, please, please don't lose points. When you see negative exponents, there should be like red flashing lights and sirens going off in your head. Don't do it. Don't stop. You got to keep going. We need to get rid of those negative exponents. So what we talked about, how do we get rid of negative exponents? Well, take the reciprocal. Now, my 4 is perfectly fine, so I'm going to keep the 4. R is not fine. R has a negative exponent, so we're going to take the reciprocal and it's going to move to the denominator. Same thing with our s. Negative exponent, so it is going to move to the denominator. Now that everything's positive, we are nice and simplified.